Okay, slope-intercept form. I've actually been hiding something from you. We've taken a look at an equation that looks like this before. However, I have to admit I didn't tell the whole truth about it. This is linear. It will graph a straight line, but I didn't actually tell you that this is the slope, whatever number comes in front of the x. So yeah, that's our rise compared to our run. And this is a special thing called our y-intercept. And we'll get to that a little bit more in a second. But this is a very powerful piece of knowledge. It will let you graph this without having to make a table of values, without having to guess and check points. We can very, very quickly graph any equation that's y equals mx plus b without technology, without a graphing calculator, as I said, without any table of values. Just graph the answer right away. So let's continue with a little bit of a definition of what this y-intercept is. So the y-intercept is where a line meets the y-axis. So if you've got a graph, and this is the y-axis, and across this direction is the x-axis, the point where the line meets the y-axis is called the y-intercept. And it always has a coordinate of 0, because you don't go anywhere in the x direction, and then you go up or down y. So you go up maybe 3, that would be 0, 3, or down 5, that would be 0, negative 5. So this might be up 1, 2, 3, that would be a y-intercept with a coordinate y-intercept of 3, with a coordinate of 0, 3, or you might go down 5, 1, 2, 3, 4, down 5. That would be a y-intercept of minus 5, and it would have a coordinate 0, minus 5. And you'll notice that the x value for y-intercepts is always equal to 0. Well, last unit we saw that if we knew a point and we knew the slope, we could graph the line. So now we know a point. Specifically, the point we know is a point called the y-intercept, and we know the slope from last unit is rise over run. So let's put that together. So as I said, as we saw in the last unit, if we know a point and a slope, we can graph the line. For example, if I ask you to graph y equals 2x minus 1, then you would set up your graph paper. I'll just sketch it. And you start by finding, first step, find the y-intercept. That's our point. And so in this case, it's 0, negative 1. So 0 and down 1 is right here. And I'll just label it for you. There's 0, 1. And, 0, negative 1. And then we use the slope. And the slope is your m value. In this case, the m value is 2. And remember, that's a fraction. So when you're doing your rise over run, you can use 2 over 1. So you go up 2, 1, 2, and you go over 1. So another point would be 1, 1. And then you could go up 2 and over 1. So another point would be 2 and up by 3. Or you can go back 1 and down 2. So if you go down 2, you would go backwards 1. And then take out your ruler and you draw a nice straight line with arrows all the way to the end of the Cartesian plane, and you're done. This is a whole lot faster than trying to graph a line with a table of values, or even pulling out your graphing calculator. This is still faster. So the last step there was draw a line and add arrows. Let's take a look at one more example of this. So here we're asked to graph y equals negative 2/3 x. So again, start with your y-intercept. I'll draw this in blue. This is really plus 0. So there's your y-intercept. And plus 0 is right at 0. And then we just apply the slope. And in this case, the slope is negative 2/3, which is our rise and our run. Or you can think about it as 2 over negative 3. And so you rise 2 and you run 3. There's a dot Oh no, I got that wrong. It's negative 2. I rise negative 2 and run 3. I go up 2 and backwards 3 and draw a line. You really only need 3 points for this because any more is just a little bit redundant. And, double check that this person is walking downhill because it's a negative slope, and everything is good. Okay, here's our next example. We want to write this equation 2x plus 3y equals 6 in slope-intercept form. Right now it's just a bunch of letters, 2x and 3y and some numbers. And we really want to make this 2x plus 3y equals 6. We want to make it have the form y equals something times x plus or minus something, so that we get the slope and we get that y-intercept. And so it takes a little bit of algebraic manipulation. The idea is we want to get y by itself. So the first step is to take away 2x from both sides. By doing that, you get 3y's by themselves, and on this side minus 2x plus 6. And then you can divide everything by 3, so divide each term by 3, and you're left over with y equals, leave this as a fraction. Why do you want to leave this as a fraction? Because, well, we'll answer that in class. Hopefully you know the answer already, but leave that one as a fraction. We don't want to turn that into a decimal. It makes our life actually a lot harder. Okay? And we can graph that. You got your slope, you got your y-intercept, now we can graph that. Of course, we could have graphed the old one with a table of values, but this is a whole lot faster if we can get things into slope-intercept form to graph them. Okay, let's take a look at a few more examples. If I tell you that I want you to write each of these equations in slope-intercept form, and the first one has a slope of negative 2 and a y-intercept of 5, you should fairly quickly be able to tell me, because of y equals mx plus b, that your slope is going to be negative 2 and your y-intercept is going to be plus 5. If I give you one where I say, hey, wait a sec, the slope isn't 2 or negative 2, it's 0, and I got a y-intercept that's a little bit more complicated. It's 1/5. Don't worry, it's exactly the same. You just make your slope 0 and your y-intercept 1/5. And of course, 0 times x is, well, the x's disappear, and y equals 1/5. It turns out that any time y is just equal to a number, you get a line that goes through 1/5 and is flat. So if you were to graph this, you'd have a y-intercept of 1/5, so just a little bit up, and a flat line. A slope of 0 again is a flat line for our person to stand on. Okay, and the last one is, what happens if I ask you for a slope-intercept form and I just give you some points? So I say, well, it goes through this point, 0, 5, and it also goes through this point, 4, negative 1. Well, I gave you a nice point. I gave you a y-intercept. So you already know y equals mx plus 5. If I didn't give you that point, this would be a much harder question, but there's one of the points is actually the y-intercept. Now I need to figure out the slope. How could I figure out the slope from this? Oh, wait a sec. We have a formula for slope when we know 2 points. It's the difference of the y's compared to the difference of the x's. So I quickly label my points, x1, x2, y1, x1, y1, x2, y2, and then I start plugging them in. Negative 1 minus 5 over 4 minus 0. That's negative 6 over 4, reducing to negative 3 over 2. And now I have my slope, which means I know my m value, which means I know what my graph will look like. Brilliant. Okay, so come to class ready to do some practicing, and then we'll attack some of the homework. All right, enjoy.